When I look at domain and range, I'm thinking about x and y values. So the domain, which is the x, which is all of the x values, is all the input values that I can use that make sense for the situation or function or graph or table or whatever that I'm looking at. The range of a function is all of the output values, so the y values that make sense for the situation or graph or table or whatever that I'm looking at. So I'm going to show you a bunch of different things that you might see that, and we're going to figure out how we do domain and range for them. So the first one is ordered pairs. So when I look at a list of ordered pairs, as I said in class, I find this terribly confusing to look at. But I can see if I want my domain, which is my x values, I'm going to look at the first value in each of the ordered pairs. So my domain is, and these are fancy brackets, or braces or something. I don't know. I call them fancy brackets because it makes me happy. I'm going to list all of the x values. So I have a -3, -1, 2, and 4. It's been my experience that they list these values in one of two ways. The first way they list them is the order that you see them. The second way they list them is in like least to greatest order. Now it happens that this is both the same, but when I look at the range that goes with it, so the range is the y values. So I've got my ranges right here. So if I look at the range on that, I have 4, 2, 5, -6. These are most certainly not in order. So like I say, usually they show you the domain and range in one of two ways. They either list them from least to greatest, so maybe they would have -6, 2, 4, 5, or they list them matched up with their y values, the x and y values matched up. So -3, 4 is the first order pair, -1, 2 is the second, 2, 5. It doesn't matter as long as you've got all the numbers. Now we don't see one here, but if you do see, so let's say that we had another ordered pair like 2, 6. Okay, we wouldn't list the 2 again, because we've already said 2 is an acceptable value. It's a reasonable value for my situation. I don't need to say it twice, but we're not going to say that. Okay. Also, you can tell that this is a function because I have no repeated x values, but that's neither here nor there. Same thing with this. When I look at my domain values, I look in the x column. So my domain is 8, 10, 12, 14. My range is my y values. So my range is 24, 30, 36, 42. Now, these data values are also discrete because if I were to graph these, they would be graphed as a series of points. That's the reason I listed my data as a list, because these are unique points and unique values. So every one of these can be plotted, and if I plotted it, it would look kind of like that or like that. It would be a bunch of dots. When I see dots on a graph, that tells me I've got discrete data. And for these, same thing. I have basically 8, 24. That's a coordinate. Over 8, up 24. Over here, I've got -1, 2. Left 1, up 2. These are points that I could plot. That makes them discrete. Okay? So discrete data, your domain and range is always going to be a list like this. Okay? When you graph it on a coordinate plane, it's going to look like dots like that. Okay? Now, when we look at graphs, it gets a little trickier. Okay? So let's take a look at this first graph. As I told you guys in class, I use my patented smoosh technology. That's spelled S-M-O-O-S-H, patented smoosh technology. And the reason why we smoosh is because it's a lot easier to read these points when they're on the axis than it is to read them kind of when they're out in space, like here. Like, I mean, this is I don't know what that says, but if I get it on the x-axis or on the y-axis, it makes it a lot easier for me to read. So what I'm going to do is I'm going to take the smallest x value I see, which is right there, and I'm going to smoosh exactly what I see onto the x-axis. And then I'm going to take the biggest one, and I'm going to smoosh it onto the x-axis. And if it's connected all the way through, I smoosh that down too. So what I see there for my domain is that my x values are greater than or equal to -2. Okay, so those are my x values. Because again, my origin is right here. There's my origin. I went -2. So and since it's a dot, remember a dot means greater than or equal to or less than or equal to or greater than or equal to. A force field means less than or greater than. Okay? So when I'm looking at an inequality statement, that's what those mean. It means this one means I get to include the point, this one means I don't because it's in a force field and I can't get to it. Okay. Now when I look at the range, I'm going to do the same thing on this one. I'm going to smoosh the range. Now I only actually see values going along this one point. And that one point, even though I have a dot here and an arrow there, the arrow goes nowhere. It doesn't go up or down. It only goes side to side. So my my y value is y is equal to -1. All right. Now let's take a look at this one. Now for this one over here, I'm going to smoosh. Again, I'm going to smoosh. So the lowest x value I see is that. The highest value I see is an arrowhead right there, and they are connected solid all the way through. Well, when I've got arrows pointing in both directions, so like this is math for, and you just keep going that way. And the arrowhead is math for, you just keep going that way. Well, they're just saying you just keep going off in both directions. That means it never stops and any value is acceptable. We call that all real numbers. And the math symbol for that is this R with 2 lines through it. You can write that, you can write ARN, you can write all real numbers, do your thing, whatever, as long as you're giving me a symbol that tells me that all real numbers are valid. Okay, when I smoosh onto my y-axis, the smallest y value I have is an arrow. The biggest y value I have is an arrow, and they're connected all the way through. Same thing here, my range is all real numbers because I have all the points in between, and it keeps on going up and it keeps on going down. So that's what all real numbers means, and that's what it looks like on your graphs. Okay, let's take a look at this guy right here. Now, these two are examples of continuous data. And when I say continuous data, I don't mean it continues on forever. Okay? I mean that in between the starting point and whatever ending point I have a connected line. Every point in between is valid. So like on this, from arrowhead to, well, those arrowheads keep on going forever, so that's continuous data. It never stops. Now, when I look here, I have discrete data because these are the only values that I'm allowed to use. I can't use the points in between. So when I smoosh this down, I'm going to smoosh a dot, 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 dot. There's already a dot there. Another dot. Oh, wait, no, I just went dot crazy. There's no dot there. Okay, let's just swiggle that out. That dot doesn't exist. I'm sorry, I got away from myself there, okay? So now, just like on the previous examples, just like these examples, since it's discrete data, its dots are discrete, I'm just going to list the values that I see there. So my domain values are -3, -2, -1, 0, 1, 2. And then we don't keep going like I did. Now for my range, I do the same thing. I smoosh my smallest value, then I got a dot already, I got a dot, 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 and then I stop because I'm done. Okay, my smallest y value is -1, 0, 1, 2, 3, 4, and that's my domain and range. It's just a list because all I have are dots. We had a lot of trouble with this one on our homework. Okay, so when I look at my range, my domain, I have an arrowhead here, I have an arrowhead here. Okay, so that means my domain is all real numbers. When I look at my range, I have an arrowhead up here, but down here I don't have an arrowhead. If you don't see a bubble, so if you don't see a force field or an arrow, you have to assume that you can include that value. So I'm going to smoosh a dot. So this tells me that my y values are greater than or equal to -2. Okay? And then we had some confusion on this one too. When we looked at, a lot of people said, well, the dot started here and it ended there, so my y values go between here. So let's smoosh. Okay, I got a dot here, I'm smooshing here, everything in between. Okay, so my domain is continuous because all between those 2 points, the line is connected. So this is going to be a between statement. My x is between 1, 2, 3, 4, 5, 6, 7, -7 and 1, 2, 3, 4, 5, 6, and I can include the endpoints because those are dots. Now, when I look at my range, I'm not looking at where the dots are. I'm looking at the lowest point and the highest point. And if I don't see a circle, if I don't see a bubble or an arrow, I assume that I can include it. So I can include those points, and all of these are connected all in between, so every point in between is included as well. So my range, my y's, go between 1, 2, 3, 4, 5, -5 and +4.